think we've waited long enough, so we can get started. I'm David Havenga. I'm from sunny South Africa. I'm a after-sales technical manager for some of the regions that we cover in GoodWe, Europe. And I'll be taking you through our troubleshooting webinar. So today we'll go through some of the after-sales organization, the online support tickets, our RMA process, troubleshooting documents, our hybrid inverters, a bit of troubleshooting on our GoodWe batteries, the on-grid inverters, and then some of our monitoring devices. So typically, as we will have questionnaire number 1, so please everyone remember to click on the Google form. The first questions are just general questions, so you can just answer them quickly. So first, for a lot of the questions, if you have any questions regarding GoodWe PLUS, please go to the GoodWe PLUS page on our website and scroll down. There you'll find our FAQ. This should have the answer to most of the questions you have. Majority of them should be there, so you'll know when you'll receive the information, all of these different questions you might have. Please go there. If there isn't the answer or the question is not there that you have a query to, please contact your support team, as I'll show you which support team to contact as we go forward. So GoodWe's after sales. We have competent local technicians all out Europe and in South Africa. We do remote troubleshooting and commissioning support. We are also, all of our support teams are supported by level 2 engineers such as myself, or in the EU time zone. We also have flexible resources with service partners to adapt to our growth. We do a quality control by unified ticket and phone system across the MEA. So we are KPI driven. So we always try and stabilize to monitor how our service is performing. So with all of this, we try to give the best and most efficient service we can. Here's a brief overview of all the services we offer by country. I won't go into too much detail. You can just have a look and see for the different countries what we may offer. But we do have a hotline for all of the customers to call, so different countries might report to different countries, as long as the language is more or less the same. And then how do we contact technical support? So as I mentioned with the FAQs, if you have any questions that isn't answered by the FAQ, you can please contact the support for your country. Here you'll see all the different countries and all the different support emails as well as telephone numbers. So when you email these, it will also create a support ticket, but we'll also show you how to create support tickets by using our support website, which is support.goodwe.com. Oh, thank you. I'll be sure to fix that for the next one. Thank you, Nicholas. So how does our after-sales service process works? So first we get the inquiry by you, the customer, to one of our service hotlines or through the service ticketing system. We then do troubleshooting. If the troubleshooting is not successful, then we go through and our teams will assess and advise you that we would need to then RMA and advise. Thereafter, we would do a bit of forms and all of that, replacement product. So then that product is then replaced on site, primarily done by the installer. Thereafter, we then collect the faulty device from you and inspect the device and then confirm the warranty. So our support ticketing system, so it's there to create tickets, to appoint then they'll CC in 5 different email addresses and create 5 different service tickets. Seems my internet might be a bit unstable. I'm very sorry about that. Just give me 1 second. I do hope that's better now. So yes, the ticketing system is there to help you and help us be more efficient. You can also create one account if you have multiple technicians in your company. You can also just share that login for that account so that everyone can watch and monitor the tickets from one platform. That way things don't get complicated. Unfortunately, with emails, we generally tend to CC everyone in the emails, and then that creates a lot of chaos in the ticketing system, because when we reply, typically the ticket system won't reply to everyone. Then we'll have a follow-up from 5 different people for the same ticket. So it's always best to use the ticketing platform where everyone can log in and view what is happening. You can also view the status of your tickets. Also, viewing it online has the benefit of, should we send you any tools or any firmware files or anything like that, that you'll be able to access it. Unfortunately, email boxes for most of the tools or firmware files that we might send out will those emails. So a lot of times we'll then send a link if those emails are blocked. But if you are accessing everything through the support ticketing system, then you will see everything and receive it immediately. So first you can go to support.goodwe.com. There you'll see there's a sign up. You simply put in your name and your email address. Thereafter, a confirmation email will be sent to you to finish the registration of your account. So even if you have contacted our support before, you can still go through this process. All the tickets that you have created with your specific email address will then appear once you have created your login. So you'll see on the email, you'll have a button that says accept the invitation. Thereafter, it will redirect you to set up the password for your account. So now that you've logged in, or even without logging in, you can go to our knowledge base. So in our knowledge base, we have a wider range of FAQs as well, where you can go and search and see if the problem you are experiencing is noted there and how to solve your problem. So we do try and always keep this updated. So any very common problems you might find here on the FAQs. But should you not be able to resolve that by using the FAQs, you can then create a ticket. So here you'll go to My Area, and then you simply click Add a Ticket. So when you create a ticket, it will ask you for a lot of information. So firstly, you'll see it will just ask who are you, where are you from. You need to input your region correctly here, because it's quite important for us to have that correct region, so that the ticket goes to the correct support department. If you do not fill in your area correct or the region correct, it might go to the wrong ticketing system or the wrong service team, and it will cause delays in response on that ticket. Next, which is the most important part for us, is the serial number. So it's very important to give us the proper serial number, the full serial number of the device. That way, if you are experiencing a problem, we can immediately start an action and try and assist to resolve the issue. Without the serial number, you will most likely get the first response from our service team requesting the device's serial number. Then yeah, you'll just see a few more things. So just communication mode, just to know how your inverter is communicating to the portal. Then a brief subject to describe the problem that you are experiencing. Always try and keep this a bit more unique. Very often in English we'll have 100 people make GoodWe problem, and then they don't provide us a serial number and might follow up later with a serial number, and then we can't link the two. Next, we have the description. So yeah, you can give a detailed description of the problem you are experiencing. If you've followed any FAQs and done any fault finding or anything like that, please give as much information here as possible. The more information you provide us, the more efficient we can help you. If you've done testing, if you've done metering with a multimeter, if you've done anything, please document that and then respond to us. You can see you can also attach files here up to 20 megabytes. So if you're on site and you take certain measurements, just take photos, take videos, anything like that, and attach them here to a ticket. What this will do is it will enable us to immediately see what the problem is, and if it is indeed a faulty device. If it is indeed a faulty device, then we can immediately initiate a replacement process instead of having a look first and going through different steps. So once you've submitted the ticket, you'll see you'll be informed of the status. You'll see in my area, you can see the status of your ticket, all the different tickets you have. Are they opened, or they closed, or they're on hold? You'll also receive an email to your registered email address when there's a status change, or if a ticket is registered or closed, or when we send you a message. So you'll always receive an email if anything happens on your ticket. So then to reply back to the ticket, you can go log into the online platform, simply reply like a web-based email. You can just reply to us on that ticket directly there, or you can reply to the email that was sent to you. It is also very important for us. So if we do come and close the ticket and resolve the issue that you are experiencing, you do not in future reply then back to this old ticket again. Unfortunately, it happens too often because we do leave it open so that if you reply and the problem is still happening after a short period of time, the ticket will still reopen. But we unfortunately get something that 6 months or a year later, we are experiencing a new problem or a different problem on the site. Then we go and search our emails and find the email from 6 months ago and we reply to this email. As we are KPI driven, this does unfortunately affect our KPIs because now it looks like we've taken 6 months to a year to respond to a ticket. So please always, if you are experiencing a new issue, please create a new ticket, even if it is for the same device. Please just try and create a new ticket for it. And next, your feedback is very, very important to us. So when a ticket is closed, you will always receive this email, your ticket number has been closed, and we ask you to rate our service. Please simply click on one of the icons. So was it excellent, was it agreeable, or was the service poor? Just to rate our service. We need to know how our service teams are performing. So if we don't get ratings, it's very hard for us to know how they are doing and how you perceive the service that you are receiving. So it's very, very important for us that you rate the service once a ticket is closed. If it is poor, let it be poor, then we can help and identify where they might need improvement. But if you are satisfied, which most of the times we don't get a rating back, because when everything is solved, the customer is happy and you've moved on to your next installation or anything like that, then we very rarely hear back that they've been doing well. So please, it's also very important for us to know when they're doing well and when they are not doing well. So now the RMA process. So RMA stands for Return Material Authorization. It's the formal process for repair and exchange of a product. So typically we would only take a properly filled out RMA form into analysis. So when we have a problem on a device, I'll show you the RMA form soon, based on what the problem is, we need all the information regarding that problem. So if you are having a problem with your strings, or the string configuration might be an issue, or anything like that, we need to know what is the string configuration, what modules you are using, all that kind of information. But if you're having a battery discharge issue or anything else like that, the PV string information is not very important for us. So it is very important to make sure we have all the information that we need to approve the RMA. Very often the service teams will also send you a list of questions. Sometimes we will get one answer back out of 3 questions, and with that we can also not close the case completely because the rest of the questions are unanswered. So here's our GoodWe RMA form. As you'll see, we ask some of the information here, the name of the end user, the address of the installation, the product serial number, which is very important to make sure it's correct. Then we have the delivery address and contact number. This is for our shipping, so that we can ensure it is shipped to the correct location. We don't want to necessarily always ship it to the end user because no one's home, then we can't deliver it. So it's better then to ship it to you as the installer to ensure that you receive the device, and then when you are ready, you can go and replace it. You'll also find we have the installation date as well as the date of failure when you've experienced the problem. So yeah, below you'll see that next we have the symptom and the frequency of the occurrence and the influence. So it's very important for us to know exactly what the problem you are experiencing. If it's not clearly described in the email, then please make sure that it is clearly described in the RMA form. If any testing or anything like that was done on site, any FAQs, anything like that, yeah, you can also put in the description of your test and the result of the test. One thing that's always important with almost all of our RMA forms is just to include a few pictures. So the picture of the installation. So if you do go on site, please just take a picture of the installation as well as a grounding measurement to make sure that the inverter is properly grounded. And the grounding measurement, we want to see the inverter's ground. No, don't want to see the grounding measurement in the distribution board. We want to see the grounding of the inverter itself. So from the inverter casing to the grounding system. So you'll see in the RMA form that will always be there. And here's the form for our hybrids, which is quite similar. The only difference here is it adds the batteries and the backup loads. So now we have the questionnaire. So we can go through some of the questions. I'll just put my email address. So as you see, these first few questions was just some general questions. What do you use? When do you use it? So question number 1, in how many languages does GoodWe offer technical support? There's quite a few languages. I see for some reason the answer is only on this page now. So we offer our local first level support in 9 local languages. So I won't be answering the rest of them for you. So where is the head office located for EU? So normally we'll put our head office first, which is a good hint. Question number 3. How is the customer notified if the ticket status has changed? So there's only one way that we notify you. Question number 4. In which section of the ticketing system can the articles or FAQ be consulted? It's the only area where you can get some knowledge. And then the last question for this section. What is the most important information to provide when submitting a support ticket? Well, I hope everyone has been answering them as we're going. So instead of delaying, I think we'll move on to the troubleshooting. So first of all, we have the hybrid inverters. So the hybrid inverters are much more complex when it comes to troubleshooting because we have a lot more areas to pay attention to. So we have the PV modules, the batteries, the utility, the meter and the CTs, the monitoring system, as well as the inverter itself. So there's a lot more to look at when we are fault finding or troubleshooting a hybrid inverter. So when my customer reports a problem, where do I begin? So we'll go through what you need for diagnosis, how to remotely diagnose on SIMS portal, and then a bit of on-site inspection. So these are some of the typical tools you'll use for fault finding. Insulation resistance tester is always a good tool to have for a PV installer. That way we can make sure that the distance from our strings to ground is sufficient. The way that works is it injects either 600 or 1000 volts into those cables, and then you can see whether any of that voltage is leaking to ground. So when we have isolation faults or anything like that, an insulation resistance tester is needed to test that. And if you have basic tools, DC power supply, which is not vital for a hybrid, but it is much more convenient when you are doing on-grids, your general crimping tools, and a multimeter. So first we're going to do a live demo. As you'll see, some of the information here is in the slides. So when you do review the PDF version later, that you can see what's going on. So here we have the SAMS portal. As you'll see, we have an alarms page, which now needs to refresh again. And then we have the normal SIMS. So in SIMS, as you'll see, all our inverters, we have the graph. Here we can do some fault. We can see how the inverter is working. We can see the operating mode. We can see our batteries as well as the percentage of the batteries. Currently, the system is a bit offline, so it's not showing us the correct information. Then first of all, we'll have our energy flow diagram here and the devices tab. So in the devices tab here, we can see a lot of information, the model, the serial number. We can see the capacity of the system that we put in, so the inverter's capacity, unlike the PV capacity here on top. The inner temperature of the device, the output power to the utility side, the output voltage, which is the utility voltage, as well as the backup output power. We see also our DC voltages. So if we have two inputs, you'll see the voltage and current here, current and power, as you'll see VAA. We have the status of the battery. And then next we have warning, charge current limit, and SOH. These values are dynamic values from our battery BMS, and they will always change based on the BMS's requirement. So normally when it's normal, there's no issues, you'll see normal from the BMS. If there's a warning or alarm, you'll see that pop up here from the battery side. The charge current limit and discharge current limit. So when a battery is 100% full, or if the cells are unbalanced and it doesn't want to be charged anymore, we'll see the charge current limit will go lower. Same with discharge. If the batteries are completely empty and we can't discharge, then the discharge limit will go to 0. And then the state of health, which is the health of your batteries. And lastly, we have the firmware version of our inverter. Next, we have the curve section. So it's nice to see this nice drawn graph here, but unfortunately, sometimes we need to see a breakdown of the information, the more individual information. So in the curve here, we can see here we've got a drop-down list. Here we can see the voltages, individual voltages of each MPPT and how it's operating, as well as the current, UA, which is utility voltage, IAC, which is the AC output to utility, the utility frequency, and the voltage of some of our other MPPTs, working mode, which is the mode in which it's operating, the temperature, the production total, PV generation, the power meter. So very often when we do installations of the power meters, we can come here to verify that the power meter is correct. Single phase is much easier. 3-phase also, we have individual breakdown, P meter 1, P meter 2, P meter 3. So we can view the individual phase data. Here we can see at night, no battery discharge. Everything is below the line, so it means we are consuming power. So then our meter installation is correct. And then you have all the backups. So backup voltage, we'll also have a look in some of our fault finding for default faults to come and look and see what power is running on our backup output. The voltage of the battery, iBattery SSC, BMS temperature, charge I max. As you'll see here, you can also see, I can probably show you an example of when the battery is full. So when our battery is getting full, then it's going to stop the discharge or stop the charging of the battery. So if your batteries aren't charging full, you can always come here and have a look and see, is my BMS limiting my charge? If the BMS is limiting the charge, it could be a battery-related problem. And then same we have the discharge Imax. Also note the charge Imax will also lower if your batteries are very cold. So based on the batteries, when your battery is normally below 10 degrees Celsius, your charging current will go half. So yeah, we can see a lot of information which is available in fault finding different scenarios of our inverters. We also have the alarms page here. So in the alarms page, you can see what's happening, what's recovered, what's all. You can search your plant serial number here as well, and then you can go and view details. So the details will give you information, so possible reasons for the alarm, as well as troubleshooting to do. So if you have an alarm, you can already go view, see what the possible troubleshooting is, and you can already follow some of these steps from the SIMS portal before you even go to site. You can already have a good overview of what's happening. So next we have the on-site troubleshooting. So on all of our inverters, we have LEDs that give us a lot of indication. I won't go into too much detail here because each different model of inverter has a slightly different variation of the LEDs. Also, the newer ones also have different LEDs. You can always important to make sure this guide, as you see here, is always in the user manual for your device, as well as on the left-hand side, printed on the side of the inverter as well. So you can always reference that to see what is my inverter indicating. So typically we don't look at the LEDs a lot, only if we are experiencing a problem. Normally we'll ask you what the LEDs indicate if we cannot get any data on the SIMS portal. So if we don't have data online, we can't see what's going on in the inverter, then us to have a look on the LEDs so we can inspect to see what the condition is, especially when it comes to Wi-Fi. But normally, if you have a Wi-Fi problem, it's not online and we can't see why. So next we move over to PV Master. So PV Master is the tool for our hybrid inverters. So yeah, you'll see when you open PV Master and connect to the consumption from the utility. You can see our safety code, the working mode, the battery model, if there's any BMS warnings, as well as the meter status and the backup output. So all the vital information is here already for us. Oh, sorry, unfortunately today is a bad day. I don't know why my internet is giving me a bit of problems. Perhaps I need to restart it quickly. So the screen will just go blank for a minute and then I will be right back with everyone. Hi everyone, apologies about that. I hope it will be more stable now. So next with PV Master, we can see the alarms. So if we are experiencing a problem on site, it's always best to go and view the alarms that we are experiencing. So you'll see in the bottom, we just go to parameters. Parameters will open in the data tab, and then we go to the alarms tab. So under the alarms tab, you'll see it will show you up to the last 100 recorded alarms. You'll see here we've got the date and time of the fault, the description of the fault, as well as the operating mode before the occurrence. So if you do have any problems like this, you can also then research on our FAQ or take a screenshot and then you can send it to our team to help as well. So what this will give us is immediately the date and exact time when the problem did occur, so we can go in and have a look to see what happened. Next, we have diagnose message. So diagnose message is very often confused with a fault message or an alarm. So it is not an alarm or an error or a fault. It is simply the logic messages of the inverter. So we use that for diagnosis when very strange conditions are happening to see maybe the BMS is telling the inverter to charge the battery now, then the inverter will be charging the battery when it's not supposed to. So typically, yeah, you'll see it will just give messages. These messages very often do not make any sense. It might tell you SOC low when we've reached our on-grid SOC. So it's simply a setting. So we've reached the set point of our battery discharge limit while on-grid, and now it says SOC low, we cannot discharge the battery further. So it's basically just the logic saying, I'm not discharging the battery because the SOC is low. So none of it, all of it makes sense. We very often get customers and end users especially, my device is having all these alarms. What's happening? Is it broken? And please be aware, it's just logic messages. It's very rarely used, so it's nothing to be concerned about. Next, we have some common errors that we will go through. So first of all, we can diagnose this from SIMS as well as PV master. So this error is the backup shutting down of the inverter, especially where in countries like South Africa, we use the backup of the inverter constantly. So very often we can have the backup shutting down, and that can be for many reasons. So first we need to confirm the peak load demand. As I said, in the curve on SIMS portal, we can go there and view the peak demand. I'll show you an example of that shortly. And we can also view the maximum discharge and charge current on SIMS portal. As you'll see in this example here, we only have 74 amp charge and discharge. So this is a 4.6 kilowatt inverter. At 74 amps at 49 volts, we only have about 3.5 kilowatts of discharge power available to us. So should our loads be larger than that, even though the inverter can do it when there is utility or solar, when we only have batteries, we are limited to that battery discharge power limit. Then we can also look at what type of loads are running. So sometimes we can't see the load that causes it to shut down, especially if it is inductive loads, motors, pumps, anything like that. Unfortunately, inductive loads are very evil loads because when they start, they can draw anywhere from 3 times to 12 times the rated power on startup, especially if they are getting older and aging motors or fridges and things like that. Sometimes they do unfortunately start to draw that 6 or 7 or 8 or 10 times the rated power on startup, and that over time can cause issues for the backup of an inverter, especially when we only have batteries available. And then lastly, we need to make sure we have batteries before we connect loads to the backup output. Sometimes we might not have batteries available and we install the system already, everything connected to the backup. When the grid is there and the solar is there, the backup is working. But as soon as the grid fails and there's any load increase, the backup shuts down. And we can damage the inverter by doing this regularly. So it's not advised to install backup loads if you don't have a battery connected to the inverter. So here's some examples. As I said, we have a look. So when a system is running and the grid is there, our inverters can overload for a lot longer period of time. So it will give you a longer breath than with the upload time. So our inverters upload every 1 minute data to the portal, and we see that in a graph of 5 minutes. So very often we cannot see the exact load. So when the grid is available and the device shuts down, typically you would see the load like this. This is a 4.6 kilowatt inverter, the ES5048. It ran for a certain period of time on this high load and then it shut down. So that is very clear and cut. But unfortunately, when we only have batteries available and our discharge limit is set as it is, that load won't run for an extended period of time before it's shutting down. It will shut down almost immediately if we're exceeding the battery discharge limits. And then we won't see the load. So in the back end, we can see that it will give us some error, almost like a short circuit or something like that, because of the load, a sudden load that's too big for the backup or the batteries to handle. So next error we have is phase order fault. So this is for our 3-phase inverters. They are sensitive to the phase order or direction. So they always want to make sure we have a right-hand rotation of the phases. So for most homes, it doesn't really make a difference. Most people don't even use phase rotation in their homes because they don't have 3-phase motors or things running. Only with a 3-phase motor does that phase rotation really be a requirement. So the inverter just makes sure that the phase rotation is correct. So when we install it, connect the grid, we might see the inverter just stays in fault. And in PV Master, we can see the alarm for phase order fault. And then we simply just swap phase 2 and 3 around. And then we should then restart the inverter and see that the phase order fault is cleared. The only thing of this one is this typically creates another mistake, and that is our meter wiring, because everything is wired up. We install an inverter, we install our smart meter, now we're switching on to commission, we have a phase order fault, we rectify this for the inverter's happy, but we've not rectified it on the smart meter. But we'll show what that effect has a bit later. So next most common fault is the meter installation. So as you'll see with meter installation, we'll see that meter data is above the line, so export at night. Our batteries do not discharge and they remain full, because it is a default logic of all of our inverters. When we detect export, we will first try and use that export to charge the batteries. So if we have a third-party on-grid inverter or anything like that connected, we'll try and absorb that to charge the batteries. So that's why the batteries will remain full. And also if we're using zero export, like we need to in some of the countries, we'll see almost no PV production whatsoever, maybe only for charging of batteries. But in this case, the batteries would be full. And as well, you'll see there's no load. It shows the load profile very, very low at 0 at night, because the consumption is counteracting with the meter data. So here's an example of where the phase rotation caused the problem for a customer. This customer installed the inverter, rectifies the phase rotation, and they set export power limit on and to 0 with the unbalanced output enabled. So the unbalanced output of our inverters, the ET inverters, enables individual phase limiting. So if our smart meter is not the same as the smart meter's connections are not the same as the inverter's connections, that leads to this problem. So I went to SEM's portal. I saw, yeah, okay, we can see it is exporting, but it's not supposed to export. Let's see whether it is a meter installation issue or it is something else. So I went to meter phase 2. Well, phase 1 didn't have it. Phase 2, yeah, I could see, okay, here's the data that's probably showing the export is on meter phase 2. Because phase 3 and phase 1 didn't really have any export on it. Then I go to IAC2 to view the AC output of the inverter, and I see the inverter is not producing any notable power on the output number 2. But I find on IAC3 that here's all the data that matches that output. So what happened is we rectified the phase rotation error on the inverter, but we didn't change it on the smart meter as well. So the inverter sees loads on phase 3, it produces, but it's metering it on phase 2. So then it just gives the maximum it can, because no matter what it produces on that phase, it's not reducing the consumption on that phase. And then we see export. So it's very important to make sure our meter installation, the wiring to the meter, is the same as the inverter's wiring. So correct CT placement is very important for us as well. All of our hybrid inverters will typically come with the smart meter in the box, so you don't need to purchase anything else. The CT comes with a cable. It's typically around 5 meters. We should not extend that cable. They can be extended. It's not advisable, but maybe 10 or 15 meters maximum. But I wouldn't advise extending your CT cables. The longer the cable, the lower the accuracy, the more loss you have on voltage. So the longer you have that cable, the less accurate your readings are going to be. Then we also need to make sure that the meter is placed on the correct location. So as we see, it shouldn't be below the inverter. It shouldn't be between the inverter and the loads. It should be between the utility meter and the entire premises. So always as close to the utility meter as possible, between the inverter and the loads. This is so that it can detect any export from the inverter as well as all the consumption of the loads. When we put the CTs here or here, we get very, very strange readings, and it's very hard to diagnose especially if you install it here between the inverter and the loads, because it will show import, export, import, export, and it doesn't make sense. So it's very hard for us to troubleshoot that. So always make sure to use the provided CTs. Try not to extend the cables at all, and then everything should be correct. So on all of our CTs, all of the years I've been working with GoodWe, all 6 years, I've never had the sticker be wrong. It's always correct on the CT. The arrow must always point towards the grid. So it's K to L, house to grid. It stands on the CT, you'll always see it there. Please always make sure it is correct. Same with three-phase, you get CTA, CTB, CTC. Also with the K to L, house to grid. We always try and reaffirm this over and over again. K to L, so it's from the house to the grid. The arrow must always be pointing towards the utility. When we install our CTs, sometimes we might think they're backwards. So if you look at the CT wiring here on top, you'll see CTA is on 7 and 8, CTB on 5 and 6, and C on 3 and 4. So they're from right to left on top of the smart meter. Please always pay attention to this. I know very often the customer's distribution board is full. We can't put the smart meter into the customer's distribution board, so we put it in a subboard next to that. The easiest way then to run our CTs is to remove these cables, run them through, and then put them back. Please always pay very, very careful attention to installing the CTs back, that A, B, and C are correct. The polarities here are correct, because if you swap the polarity, then the CT direction will be incorrect according to the sticker. So if our polarity is correct here, then our sticker is 100%. So always be sure to, if you remove them, to install them back the exact same way. You can find our user manual for the smart meter. We also do have an indication on the side of the smart meter, but I always urge you to take photos, mark your cables clearly, and make sure that we install them back correctly. Because this also makes it very hard to troubleshoot if these have been changed. So remotely we can do very little to help if this is wrong, but typically if you have removed these, please pay careful attention to make sure you've installed them correctly back. As we affirm here, you'll see it's A, B, C from right to left. It's very important to note this, because from the bottom of here we have the voltage sense, and the voltage sense is different. So the voltage sense is from left to right, A, B, C. So on top it's CBA, the bottom it's A, B, C. It's very important for us to also make sure that this is correct, the correct voltage input for the correct CT. If we have the wrong voltage input for the CT, so if we've put them all from left to right and left to right, then we'll find that A and C will have the wrong voltage input. And when you have the wrong voltage input, essentially you are reading the current out of step. So then it will see that current, probably 50% of the active power will be read, and we'll also see it in the wrong direction. So typically if our CT is the wrong way around, we'll see the right amount of current flowing or the right amount of power flowing, but in the wrong direction. But if our voltage sense is incorrect, we'll see the wrong direction as well as incorrect amount of power going through the CT. So it's very important to make sure that our voltage sense is correct. So if we fix that phase rotation error, we swapped 2 and 3 around. We need to make sure to swap 2 and 3 around here, as well as move the CTs for 2 and 3. Not these ones, those ones. So we need to move these 2 around and flip these 2 around. So then for our smart meter, especially when we're installing this with only an on-grid inverter, so our hybrids give us all the information from the smart meter. We can read a lot of information. We can even run a meter test for the smart meter on the hybrid inverters. But when it comes to the on-grid inverters, the communication with the inverters aren't the same. It's very much just some data points it's getting, and then it reacts on those data points. So the only way to make sure our installation is correct is to verify the LEDs on the smart meter. We can also do this for hybrids. So if the smart meter is on the other side of the house and we've extended our communication cable from the inverters to the smart meters, you can extend that cable. The inverter comes default with the 15-meter long cable. You can replace that entire cable with up to 100-meter long cable. Don't use an extender on that. But yes, yeah, you'll see. So the top orange LED is the power that needs to be on. So if we have power to the smart meter, that needs to be on. If it doesn't come on, we would obviously know that it's faulty. So that can happen. Next is the blue LED. So that's our energy flow. So when it is solid, we are consuming power from the utility. So if your inverter's off, there's no PV production, no battery consumption. Everything should be coming from utility. We should see that light solid. If that light is flashing, we know it's exporting. So if there's no inverter connected yet and that light is flashing, then we know we have a problem we need to solve. And the last is the COM LED, so that if it's connected to the inverter and communicating, it will just slowly flash the whole time. So you can also compare the energy flow to the actual on-site load behavior with a multimeter. So you can turn on some loads and see how it reacts. So next we have the smart meter test, like I mentioned. So sometimes a smart meter test can fail for multiple different reasons. So first of all, we need to make sure that our meter is communicating correctly with the inverter and that the EMS comms and everything is correct. So the smart meter test does fail when we have less than 150 watts per phase consumption. So if our consumption from utility is too low, so if our PV is producing and we're zeroing the consumption from utility and we run the meter test cannot accurately judge the direction of the CTs. We need to make sure we are consuming more than 150 watts per phase from the utility when we do the smart meter test. So very often we can put the solar off and then do the smart meter test. Next, if there is an issue with the BMS communications, the smart meter test may also not complete. So then we can fault find the batteries. If the smart meter is not properly connected, so like I said, we can extend that cable. So the smart meter communication cable, the one in the box, sometimes we route it, it might get damaged or something like that. Or if we use a RJ45 extender, those network extenders, they're not designed for RS485 communications and can cause interruptions. So never use a network extender plug to run a longer cable. Always replace the entire cable. That way there's no points for interference. The RS485 is very susceptible to external magnetic fields, and anything like that can cause the communication to fail. And then lastly, the smart meter could be damaged. We probably get 1 in 1,000 if that are faulty or may fail. And then we can replace that meter for you. Next, we have abnormal charge and discharge. So we'll see on the SEMS portal strange behavior, like battery charging at night without PV. So when our inverter is set to general mode, it should only charge from excess PV that's available. So we need to run PV master and we can do the meter test to make sure the battery and meter communication is correct. We can check if the customer has maybe set an economical mode timer. We can switch off the supply to the meter and observe the COM LED if it's going to start flashing. And then lastly, we can check the communication cables. Here's some more examples of unexpected battery behavior, where the battery does not discharge, of the battery charges and discharges at strange times. So when can this occur? So when the CTs are incorrect, as I explained earlier, the batteries will remain full and won't discharge. We need to make sure those CTs and meters are installed correctly. If the CTs are not on the right place as well, we'll also see strange behavior from the batteries. The incorrect settings in PV Master, like I said, we need to double check and make sure that our economic mode timer is not set. When the battery SOC is very low, so especially in Europe or anywhere in the world, when we have no PV for a long time and our inverter is set to general mode, so we'll only charge from excess PV that's available. So in these long winter times or long stormy times, our batteries will run low and will remain flat. When the batteries sit flat, they do have some self-discharge and will slowly discharge down. Once they reach a point before they become unsafe, then the inverter will automatically charge them up. So that's why typically you'll see something like a pylon check might stop at 10%, then go down to 5%, and then charge back up to 10%. So that is very normal. Next, if our loads are less than 50 watts, the battery does not start to discharge, especially if we are using zero export. When we have less than 50 watt load at night, the battery won't discharge for that 50 watts. And then lastly, if there is a communication error with the smart meter or the BMS. So next we have a condition that can occasionally happen. So sometimes we might install the inverters when there's no grid. So there's no grid, it's fully off grid. So when the grid is there, we know we're always connected according to our wiring regulations in our countries. We connect our ground, our live and neutral from the utility, and all of those connections. But when we have no grid, we need to make sure to always connect the ground. So typically this is for safety. It's for safety of the product, for safety of the customers. We always need to make sure that there is grounding, because we're creating grid here, we're creating a thing that has potential to cause a shock. So everything needs to be grounded. So even if you create your own grounding network at the site, the body of the inverter needs to be grounded, as well as the terminals of the inverter needs to have that ground connected. Otherwise, the inverter might not start at all because it detects there is no ground. So please always refer to the installation manuals. So if there's no grid, you can ignore the live and neutral, but the grounding always needs to be there. And then we have the next set of the questionnaire. I hope everyone has been answering them as we've gone through. I'll pull up the next ones. So as we see here, please always remember to press next, and then we'll go to the next set of questions. So here the first question in the third round of questions is: the ET inverter is stuck in a fault mode due to incorrect phase rotation. What is most likely the root cause? I think that should be quite easy to answer. Next, on the CT, the following is written K to L. To which side should the arrow point when installing? I think I've repeated that many times, so I hope you can all answer that without a hint. Next we have, where should the meter be installed? So the meter CTs, where should they be installed? It's always important to install them in the correct location. Then we have a more complicated one. With a three-phase smart meter, how is the voltage sense and meters wired? The ALC will show you in the picture. So always pay attention to where A is, and then we'll make sure our meter is wired correctly. And then the last question, where can you view faults that have occurred on your system with PV Master? I can tell you for sure, it's not diagnose message. And then remember again, once you've completed all the questions, please press the next button. And then we move on to one of the new sections in our troubleshooting. So some of the common errors on the GoodWe batteries. So some of the questions we might receive, well, you might send me in the Q&A. I'll go through them near the end of the webinar, or if we get to a part in the webinar where we have that as what we're showing, then I will answer the questions, because I see we do have one for the DC isolation. So next, one of the common errors for the batteries is the battery might not communicate with the inverter. So we need to make sure that the SOC indicators are indicating normally on our batteries. If there's any alarm or any fault in the batteries, the SOC indicator will indicate the alarm that we're receiving. So we need to make sure that the DC breaker is on. We press the power button once on the batteries, and then we can view and observe the SOC indicator. If the SOC indicator is normal, we also need to make sure that our termination resistor is installed on the last battery. So if we only have one battery, it will be installed on that one battery on the open terminal. And then next, we need to make sure the batteries are properly configured on PV Master. If we have an alarm on the SOC indicator, we can view and see what the alarm is in the user manual, and that will give us an idea what we need to do. But if the indicator is showing a low battery or anything like that, we'll follow the next steps. So when we start up a battery, we'll see the indicator might indicate low battery or anything like that. It's not really giving output. We measured with a multimeter, we might see approximately 32 to 34 volts. And that means the battery hasn't engaged its internal relay. So typically we can then force it to go on. We can ensure that the DC breaker is on, it's connected to the inverter. We press the power button 5 times within 10 seconds. So that power button will press 1, 2, 3, 4, 5. And then we'll wait. Observe it for a few seconds, see whether the LED is going to normal. It'll show our normal state of charge. If it doesn't, we repeat again, 1, 2, 3, 4, 5. See if it's working. So especially some of our batteries, like the CQA, that's with our ESA, our all-in-one inverters, those ones that process might take a few times to get it to activate. So we'll just have to repeat that process. So 1, 2, 3, 4, 5, until that SOC indicator goes normal and just shows our 1 or 2 bars of battery charge. Then we'll know everything's gone to normal. If the battery is still in a very low state, we can then make sure to charge our batteries up, especially if it's going to be standing or anything for any extended period of time. If the PV is not there, or if we're still busy commissioning the site, we can then just charge the batteries from utility to make sure they're on a good level. So then we can wait until the grid and battery LEDs of the inverters are on solid. And with PV Master, we go into advanced settings, and we'll see there's a battery fast charging option. We can just set that and set it maybe to 30% just to charge the battery up to make sure it's on a safe level, and then it will charge up. So if we're installing this from an older inverter, we'll just have to make sure that our firmware versions are correct, on the correct versions, to enable to use this feature. And that way we'll know our batteries are correctly charged. And especially if we need to store the batteries for longer or anything like that. I know some countries you might have to install, and we wait for utility to come to the site before we can fully switch on and commission the system. So just make sure to charge those batteries up, and then we can switch the system off and leave it till the utility company comes to have a look at it. So then we'll move to our on-grid inverters. So the same basic tools are required here. As I mentioned, the DC power supply is a great tool to use here, especially if we are having any faults like insulation errors on the inverter, or if the inverter is not starting up or anything like that, we can use a DC power supply. Because most of the on-grid inverters only power up from DC, or if you need to do firmware updates at strange times, it's always good to have a DC power supply handy. So with the on-grid inverters, although our inverters do have reverse polarity protection, it's always good to make sure that your polarity is correct before connecting to your inverter. Same with the AC terminals, make sure that our terminals are well connected and the voltage and everything is there. So these are also preliminary checks, so if you're having an alarm or a fault on the inverter, always do these checks to make sure everything is okay, and then connect it up again, restart the system and see if it's working. So one of the most common faults we'll have is an isolation fault, or a ground eye fail. So isolation fault and ground eye fail are similar conditions. So it's essentially leakage current on the ground. So isolation fault is always going to be more on the PV module side, and ground eye fail is going to be more on the utility side. So if our grounding is poor, from the utility side, we might have an elevated voltage between neutral and ground. We will have the ground eye fail. So for that, we can always just measure with a multimeter and make sure that our grounding is correct. Maybe there's a loose connection somewhere in the ground or the neutrals, and we need to make sure that that is well bonded. Then for the isolation fault is going to be on the module side. So for that, one of the quickest things to do is disconnect all your modules, test one string, see if the one string works, next string works, and then we can also test the MPPT. So find one string if it works, we test the other MPPT with that string, so if we have multiple MPPTs, we can test all the MPPTs with that one string, and if there's no isolation fault, then we can be sure everything is fine with the inverter. We now need to move on to test the strings, then we can do each string one by one. And that is just one of the quick ways to do the testing. Also, we need to measure the resistance between the module frame and the metal bracket to make sure our grounding of our PV modules are correct. So it should be less than 10 ohms. If we're testing with the modules, and regardless of our modules we tested in the inverter, we're still getting the isolation fault, we can also start up a DC power supply, see if with the DC power supply we also have an isolation fault. If it still remains there with the DC power supply, we can be sure to replace the inverter for you. Unfortunately, it does happen. Lightning may strike or anything might happen, and then a component might fail. So sometimes you will get isolation fault if one of the internal components have failed as well. But typically, if we get an isolation fault in the early mornings or anything like that, it is normally from the module side. So sometimes modules delaminate, or there's a slight cable damage under the modules. So when the humidity is high or there's dew, then we might have an isolation fault. So when there's more moisture, it's more likely to leak the current to ground. Then it's something on the modules or on the wiring to the modules that needs to be rectified. So with an insulation resistance tester, you can verify your cables. So you can disconnect your strings, your connection from your modules. Normally you'll do that unless you have a proper PV tester So PV module tester with insulation resistance testing, you do get those specialized equipment that you can just plug in your PV strings into it, and it will test the insulation resistance and everything for you and your modules. But if you just have a regular insulation resistance tester, normally you don't always want to inject, especially if you have a small string of only 200 volts, you don't inject a 600 or 1000 volts through your modules. You'll disconnect the modules, connect your cables, and do your insulation resistance test. So that will run the current through the cable, and you measure from one of your cables to ground, and then you'll see if the insulation is correct or not. So a lot of installers and bigger installers, EPCs, will also do these kind of tests on commissioning before even connecting to the inverter to make sure that everything is 100%. So utility loss, I'm sure you might have noticed when I opened the alarm page on SEMS portal, you'll see we have a lot of utility loss. Primarily this is because the grid is off. Many countries with unstable grid will have utility loss very often. Sometimes it could be that one of the circuit breakers might have tripped. So if we undersize our circuit breakers or size them just on the level, when the circuit breaker is warm, they degrade as well, and then those circuit breakers tend to trip. And it is not good for the system for a circuit breaker to trip under load. It should only trip when there is a cable fault. So we should make sure to ensure we have the correct size breakers installed as per the user manual of the inverters. And if it is a very hot area, even space your breakers just a few millimeters apart, so they're not pushing against each other, so they don't have combined heat. So just make sure of that. Next, if everything's okay, the utilities are on, our breakers are on, nothing has tripped, and the inverter is giving utility loss, then we need to measure under the inverter. We can, some of them have a cover we can disconnect and measure there, or we can unplug. So switch our AC off, unplug from the inverter, switch it on again, and test the terminals to see that the grid voltage is there. So we need to make sure those terminals are all well connected to the inverter. And lastly, if we can confirm that there is voltage under the inverter is receiving the grid voltage, but it's still saying utility loss, then we can measure the impedance of the grid port on the inverter, and it should be greater than 200 kilo ohms between live and neutral. If it's not, please contact us for support. Next, we have VAC failure. So VAC failure can occur for multiple different reasons. So this is typically when the voltage exceeds the protection settings of the safety code that you set for your country. So we always need to check. So what we can very often do, we can set the inverter to, let's say, 50 Hertz grid default. That will then not comply to any grid codes whatsoever, but it will give you a wider range of input. If it then operates, then we can be quite certain that it is some grid code related safety error. We can then verify the voltages of the utility, make sure the AC cables are properly connected, restart the inverter. What I always like to say is just, if you have a screen or you connect it via the SolarGo app, you can have a look at what the grid voltage is. If you see the grid voltage is quite high, we restart the system, let it start back up again. When the inverter is off, let's see, or not producing, we can see what the grid voltage is. If the grid voltage is within range, we start the inverter up. If we see that voltage immediately start to climb, then you can be sure there is a resistance issue. So it could be the cables we are using are too small, or I've seen the cable have right size cable. Unfortunately, the cable had a fault somewhere and caused a resistance, so which over time would have burnt the cable, but the inverter's voltage would rise the whole time and then stops producing. So the inverter always puts a slightly higher voltage out than utility, so that voltage starts to creep up if we cannot get the power away. Next, we also need to measure the voltage between neutral and earth, make sure that it is less than 10 volts. If it is higher, it could indicate poor earthing. Like I say, sometimes it's just maybe the earth is not tight enough somewhere and it's not making correct contact with oxidation on the cables or anything like that. And if it still doesn't resolve it, then you can contact our teams for support. Just another thing to add, if you're having the rising voltage, you can always take a multimeter, measure the voltage by the breaker of the inverter. If you see the same voltage there as what's on the inverter, then we can start to measure further down the line. Some countries might have a very small supply from the utility, and it could be the utility supplies issue as well, that it will be out of the grid voltage range. So if it is then out of the grid voltage range, then the utility company needs to be contacted to rectify that. And it's not something on site that one can rectify all from the inverter side. The next we have FEC failure, which is similar to the VAC failure, except it's the frequency. So just make sure that you have selected the correct country code, because typically the frequency is not a big problem in most countries. Voltage is more a problem than frequency. So just check the voltage between neutral and earth, and if the frequency is correct and everything and you're still having it, then you can contact us for further support. So next we have with our on-grid inverters, this is also including our ET inverters, the new ET Plus. So when we start the inverter remains in a wait mode. So all of our inverters have remote shutdown connection or anything like that. So some countries we might have a dread connection. So it's all things that tell us not to connect to the utility. So with all these different ones, so like the XS, the STT-G2, the SMT, the ET Plus, all come with a proprietary little plug in the box. So some of them may be round, some of them may be square. That plug already has a wire bridge in it, and it simply needs to be installed in the inverter. If we're not using the feature or connecting the remote disconnect up to something, just make sure to always install those plugs. We get it very often that it is ignored because it's not something that's used, and then once we start to commission the system, it might be a few weeks or months later and we've thrown it in the trash. Now the inverter cannot work without it, and then you need to contact us to try and get a new one. So please always make sure any of these proprietary plugs that are in the accessories, always just install them on the inverters. That way you'll know the remote disconnect is inserted and it shouldn't be a problem. Next we move on to monitoring devices. So yeah, we have the Wi-Fi. So what to do when we cannot find solar Wi-Fi, or we can see it but cannot connect to it, or we can connect to it but cannot log into the default IP address, or if the customer has replaced his router. So normally when one of these Wi-Fi modules has connected to a network, even if the network's no longer there, it's always going to try connect to that network again. Then we have to reset it. So different models and different devices have different ways to reset it. The old Fiber 4S ES has only a reset button on the inside, but with the newer Wi-Fi modules, there is a reset button on the Wi-Fi module. So we just press and hold that for 5 to 10 seconds to fully reset the module back to default. Thereafter, we can then configure it again. So this is the same for LAN modules. If anything's changed, the network customers changed router, and we don't have it on DHCP, we can use this reset procedure to reset that as well. Then next, if our customer's network is not visible or the router has a very low signal strength, so here we can see the RSSI. So especially if we're using the 10.10 interface, we can view nicely the signal strength in a number format. So it's always good to make sure that the signal strength is sufficient. I always recommend above 50% signal strength. If there is anything that could cause interference, so for instance, if there is a microwave in the kitchen, the Wi-Fi router is in the lounge, and our inverter is in the motorhome or the garage, and the kitchen is between the lounge and where our inverter is installed. So every evening, if we are microwaving food or warming food up or defrosting something for 15, 20, 30 minutes, the microwave emits a 2.4G signal, and that can interrupt the Wi-Fi communication, and that can very often cause it to not reconnect. So always make sure we've got sufficient signal strength. So next we have a few other things. Like I said, that Wi-Fi LED is very important for us to know, especially when it's not online, so we know more or less what the problem could be. So if it is too flashing, it means it's not connected to the router, so the customer's router may have been out of range or an incorrect password was used to set it up. Another condition could also be, so sometimes the Wi-Fi module might try and reconnect and reconnect and reconnect, and after a certain time of trying to reconnect, it's unable to reconnect, and then it will just sit in the stale, not connected scenario. What I suggest for any inverter that does this is call our support team to update the firmware of the inverter. So you can restart the Wi-Fi connection or restart the inverter. The connection should re-establish, or just press that reset button for a short time. It will restart and reconnect. The inverter's firmwares now have the ability to automatically restart that Wi-Fi module. So should you have any problems, it will automatically restart that Wi-Fi module. So it is something that we can do now for all the inverters. If we see the full flashing, so the full flashing condition typically could be a network communication issue that is being blocked by the router. With that new firmware, like I said, we'll also restart the Wi-Fi if the full flashes does happen, and sometimes that can rectify the situation. Normally that rectifies it by getting a new IP address or anything like that and bypassing the router safeties. But very often our router have firewalls. All home routers do have firewalls of varying levels. So if we see that the connection is perfectly fine and once a month it stops working, it typically is a very bad firewall on the router, and port forwarding the TCP port 20001 will eliminate that permanently, but the new firmware should also circumvent that. And also lastly, just if an unsupported character is used, so there's a list of supported characters, and also if there's any blank spaces in the password or the Wi-Fi name, like my space home, then it might also give you the full flashes and not properly connect to the network. So next we have if the inverter is connected to a logger but is not controlling. So similar to the remote disconnect, very often our inverters can then remain in await mode, especially the on-grid inverters will then sit and wait in await mode. We always need to make sure to configure our inverters. So when we set our on-grid inverters, we typically only set the grid code, we made sure our time is correct, we made sure our grid type is correct, and then we make sure our communication address is set for the RS485. So that communication address for the on-grid inverters should always be in the range from 1 to 60, and for the hybrids from 1 to 10. Please always make sure that we have set them and no two devices have the same address. So for on-grids 1 to 60, for the hybrids 1 to 10. Next, we also need to make sure we are using proper shielded twisted pair cables. When we talk about a twisted pair, if you use a network cable like a Cat6 shielded cable, in that cable you'll see there's going to be colors. So we'll have, for intersect, orange and orange-white, and they're going to be twisted together. That is a twisted pair. So our RS5 connections A and B need to be orange and orange-white. So we need to use a twisted pair split between A and B. Very often we find customers use orange, orange-white A and blue, blue-white on B. That is not using a twisted pair. That's using two split pairs. And magnetic interference can cause it to not work. So please always try and remember, you can double it up and put orange and blue A and orange, white and blue, white on B. So please always pay very careful attention to that. That is one of the most common mistakes that's made. And then lastly, if you have older inverters connecting new loggers or anything like that, you can contact us then to update those inverters and loggers for you. Then one of the more in-depth ones, so the EasyLogger Pro not connecting to ProMate. So when we have our EasyLogger Pro, our ACC 1000 or ACC 1000S, we need to directly connect to it with LAN. We need to make sure to download the correct ProMate. So on our website, you will find the EasyLogger Pro or ACC 1000 ProMate version 1.10. So that's typically the ProMate that's used from all of these devices. Once you've opened ProMate, ProMate will show you a nice screen of what the default IP address needs to be. We need to change the IPv4 address on our laptop. So we ensure that the firmware is updated. So for the newer ones, we don't really have to worry that much about firmware. All the newer loggers we get now should all have the latest firmware on them. We connect our laptops to the LAN port. We're then going to press the reset button. So these devices all come standard in DHCP mode, which makes it nice to plug it into a router and it's going to work. But we cannot configure it like that. So we need to press, so here on the side, we'll find a little reset button next to the USB port that can be used for firmware updates. We press and hold this reset button for approximately 10 seconds. When you let go, you'll see the LEDs will go from right to left. We need to see the LEDs cycle from right to left. If we don't see that, we need to press and hold it a little bit longer, let go, and see it go from right to left. Once we've seen that right to left, then we know the device is now set to a static IP address and we can connect to it. So then you're going to go into your computer's IPv4 properties. You're going to set an IP address. So when you open ProMate, you'll see it's nice and easy. I'll just go to the next page to show you. It's nice and easy. ProMate shows you the default IP address 192.168.1.200. So that's the IP address of the logger in default. So we'll set our IP address to 192.168.1.100. It can be anything up to 254 except 200. It cannot be the same as the EasyLogger. It needs to be one number difference, just the last number. So you can make it 1 or 2 or 3. As long as it's not 200, it will work. And then the subnet mask, which is the default 255.255.255.0. Don't need to configure anything else. Just hit OK. And then we can press connect on ProMate. It'll take a few seconds and we should see the serial number pop up. It should say connection succeed, and we'll see the firmware version on the EasyLogger. Thereafter, we can commission it and configure it as we need to. So next, one of the ones we need to do, so when we need to do load monitoring or anything like that with our ACC 1000S, we need to tick this box here that says export enabled. So once we tick this box and fill out all our information of our CT, our power of our plant, how much we're allowed to export, we'll then move over to this page. So then this box will appear where you can press the refresh button. So it's always good to do this when there is no PV production. The AC can be on, the PV can be onto the inverter, but we leave the inverter's AC power off. The reason for that is so that we're not consuming or producing any PV power to alter the readings that we're seeing here. So you press refresh and then it will give you a snapshot of the data that we're seeing. So all these values need to be negative. So negative means consumption from utility. So we need to check and verify that all these values are negative. So same with our smart meter CTs. If you are using CTs, please try not to use cables longer than 5 meters. 15 meters normally is the maximum. If you run it any longer, you need to make sure you have special CTs that can cater for that. But I would never advise running long CT cables. It does affect your accuracy and efficiency. The R285 cable can be extended very long, so it's better to install that a kilometer away and run your CT cables as short as possible for higher accuracy. But in this example here, you'll see there is something else that we need to have a look at. So because this power that it's displaying here for us is only active power, it does not display the reactive power for us. But if we do a simple calculation to calculate the reactive power, we take our current, times our voltage, it doesn't come nearby to this. The current times the voltage should be within 20% of the values we see here. Unless we have a very, 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 very bad power at a premises, it's unlikely. So if you calculate this, this should be approximately 6 kilowatts. Yeah, we're seeing 2.88, 6 point something kilowatts. So because we only see 2.88, that means we have a power factor of 0.4, 0.45. So more than 50% of the power is reactive power. So that typically does occur when our voltage sense is incorrect for our CTs. So we just need to make sure that we have the correct voltage sense for the correct CT. If we did, then we'd see that this value was within 20% of this calculation of 29.74 times 231.7. They should be close. It should be no more than 20% in any given place. Normally you're going to look at about 90%. Only very, very big factories with big motors and stuff might have an issue, but then they might need power factor correction. But just always verify the voltage input for the CT needs to be correct. So next, after we've configured it, we need to connect our logger to the customer's network so it can connect to the SIMS portal. So I always prefer a static IP address. The nice thing of a static IP address, I know very often we're not the most internet guys, so we don't really know what to set. I'd always recommend, if it's a company or anything like that, they should have IT people, and you can always consult them and get them to give you the information you need to set the IP address. So what IP address is available on the network, what's the gateway, and what DNS should we be using. Then you can set those values and press the set button. Unplug the network cable, plug it into the network, and we should have no problems. If you do that, I always recommend take a Cokie pen or something like that, and in the lid of the SEC, open it up and write the IP address there. So if in the future you need to come back to site and do anything, all you have to do is plug into the network, put that IP address into the ProMate and press connect. You don't have to change anything, you don't have to reset anything, it will just work. But if it doesn't matter and you just want to connect it and have it working and make sure it will always be interactive if they change networks or anything like that, then we can do step B, which is set it to DHCP. So from ProMate you can tick that and press set. Most of the times it will work, it will set it, you can unplug your laptop, plug it into the network and it will connect and work. If it says at the bottom set failed, then we're going to have to manually do it. That reset button. So we'll press and hold the reset button for about 5 seconds, let go. We should see the LEDs cycle from left to right. If this doesn't happen, try it again. If it still doesn't happen, then press and hold it for 10 seconds. Then we'll see the right to left, and then press and hold it again for a short period of time, and then we'll see the left to right. Then we'll be in DHCP. We can plug it into the customer's network, and we should see after a few seconds that the server LED will then go on steady. Then we have the last round of the questionnaire, which we can quickly go through. So the last round of the questions: for what is the DC power supply an effective tool? So the most effective way of testing one of the steps we showed question number 2, what is the cause of utility loss? That one should be quite easy. The next question, what is the tool called to configure the EasyLogger Pro? Should be quite easy because it's the only Pro we have. Next question, what is not true about an isolation fault? So choose the most common cause for isolation fault or ground eye failure. It's a bit of a trick question, that one. So it's probably the one answer we didn't mention. And then lastly, to set the EasyLogger Pro to a static IP address, we have to press the reset button for how many seconds? So I hope everyone has answered all the questions as we went through. You do also have a bit of time after the webinar to also just go through and finalize that. Please remember at the end of answering all your questions to press the submit button, and then that will submit all the answers to us. If you just close it or press back or clear form, it will wipe it out, and then you'll have to re-attend this webinar. So please make sure to fill everything out and hit the submit button. And thank you very much everyone for attending. This is the final webinar for this series of GoodWe PLUS. Should you not have attended or missed one of our previous GoodWe PLUS, you can just keep an eye on our website to attend one that you might have missed or anything like that. And we hope that you continue to install GoodWe in future. And should you have any problems or any queries going forward, please do contact our local support teams. They are there to assist you, to help you to resolve any queries you may have. Let's have a look and see if we have any Q&A. Perfect. I see we don't have any questions. Just ask regarding the PDF of the training that you'll receive within 1 week from this presentation. We'll send it out to all the participants. And please remember, any question like this is on our FAQ on the website. There you'll find all the answers to those questions. Thank you very much everyone for attending. We are a bit over time. Unfortunately, the troubleshooting does take a little bit longer, and I keep making it bigger. Thank you very much everyone.